Question 11. In the circuit shown below, all resistors have the same resistance R and the light bulb has fixed resistance. You wish to change the state of the switches so that the brightness of the bulb increases from its minimum to its maximum. Which sequence of switch states will achieve this? So in this question we've basically got three what I'll call configurations. First, when switch A is closed. Second, when only switch B is closed. And third, when both switches are closed. And each of those different configurations will give a different bulb brightness. Now it should be clear that the minimum bulb brightness will occur when the resistance through the circuit is at its maximum. And conversely, the maximum bulb brightness will occur when the resistance through the circuit is minimum. And so the way we would answer this question is by calculating the resistance of each different configuration and then comparing those, and that should give us our answer. So just a reminder, for resistors in series, you simply add the resistances, and for resistors in parallel, you do 1 over each of the resistance values, sum those, and then to the minus 1. So let's start off by calculating the resistance if only B is closed. So this is just B. This is the most simple configuration because here we have two resistors in series. So we have R plus R, which is 2R. Next, what about if only switch A is closed? This is slightly more complicated. Effectively what we have here is one resistance in series with this configuration here, which is two resistors in parallel. And for these two resistors in parallel, you would get 1 over R plus 1 over R to the minus 1. And therefore, you would get R plus R over 2, which equals 3 over 2R. Apologies, I've just went off the page a bit there. So if you do the maths, you get 3 over 2R. Now, what about if both A and B are closed? Well, let me just redraw the circuit to make this a bit clearer for you. So here are my two switches, A and B. And what we've just calculated basically is that we have two resistors. Just bear with me here. We have two resistors in parallel. We know that this resistor at the top, as we've just calculated over here, is 3 over 2R. And we also know that this resistor on the bottom is 2R. So if you close switch A and switch B, this is effectively just having two resistors in parallel, which would be 1 over 3 over 2R plus 1 over 2R to the minus 1. And if you work through the algebra, I'll leave that to you. You should get 6 over 7R. Now, just so that we can compare these fractions, I will write out what they are. So 3 over 2 is 1.5, and then 6 over 7 is roughly 0.86, or at least it is to two significant figures. So now, as I said at the beginning of the question, we want to go from the minimum brightness to its maximum brightness, or in other words, maximum resistance to minimum resistance. So the maximum resistance here is this one, just B closed, followed by just A closed, with then the next lowest resistance being both of them being closed. Therefore, the answer is C.